Okay, I have a lot of writing on the board. We are going to start with a really basic problem for solving with substitution. And these steps right here are all the steps that sort of outline how you can do this. Now, if you end up finding a quicker way or something, go ahead. Just make sure you check your work at the end and make sure it's accurate. To make sure your actual answer is accurate when you're finished. That's pretty much the ultimate goal from all of this. Now, we're going to start with some basic equations, or with a basic equation, or a basic system, essentially. One that we probably could graph and actually find a great answer to, but we aren't going to graph it because, again, graphing can be kind of inaccurate. Graphing can be a little bit cumbersome. Graphing is definitely time consuming. And eventually, when you get good at the substitution method, you'll find that this is really quick. There is one more method beyond this that's maybe even quicker and maybe even more accurate and helpful in some ways, but substitution is a very, very thorough way to go through this. When I actually was an 8th grade algebra student, just like you, when I was doing substitution, this is my bread and butter. I loved this one. I was so good at substitution. I loved it. I kind of still love it. You'll see, like, I love algebra, but this, this later half in the year, this stuff's good. All right, so the steps that we are going to be taking, this is sort of the general idea. If you can't read these steps, which you might not be able to, if you can't read these steps, they are linked in your notes in Canvas. So after you watch all the videos, the notes in Canvas have these exact steps in them. It's a PowerPoint. You can just copy them down. It's pretty easy. That being said, step 1. We are going to solve for one variable in at least one equation, if needed. Okay, so let's first get a systems of equations down so we can see how to work through this as we go along. So we have this system, y is equal to 2x, and y is equal to x plus 5. That is our system. If I look at these systems, it says solve for one variable in at least one equation. And if I look at this, both of these equations are already solved for y. They are solved for one variable. And that's really helpful. That means I don't have to do step 1. It's already been done for me. Then after that, it says step 2, substitute the resulting equation into the other equation, meaning we're going to cut out the middleman. I want you to think that A equals B, B equals C. We were able to write the final statement of A equals C and cut out that B term. We can do the same thing here. Y is equal to 2x and y is equal to x plus 5, meaning I can cut out this middleman of y and just say 2x equals x plus 5. And so that's what I'm going to do for step 2. I'm going to write 2x is equal to x plus 5. I'm going to cut out that y variable so that way I don't have to worry about it and I can actually start solving. If I have one equation, the maximum number of variables I can actually solve for is 1. If I have 2 variables, I need 2 equations to solve them. So I have one equation now with one variable. Right here, if I looked at this one equation, I had 2 variables, meaning I wouldn't be able to ever find one solution for this one equation because I have 2 variables, 2 unknowns. This equation now, 1 variable, 1 unknown. And so I'm going to solve this for that one variable in my step number 3. So I'm going to solve by saying, okay, subtract x from both sides. 2x minus x, I get a single x left over. This disappears into 0 x's. I mean, it doesn't disappear, but 0 x's I don't need to write down. I don't need to acknowledge that. I get x is equal to 5. 5 is the only thing that's left over. So I now have solved for one of these 2 variables. Step number 4 says substitute the solution, so this x equals 5, into one of the original 2 equations and solve for that variable. So I'm now going to take this x equals 5 and I can put it into either one of these 2 equations. I don't care which, just do it. I'm going to show you how it equals the same thing in both of them. So I have y is equal to 2 times 5, so put it in the top equation. So we get y is equal to 10. If I put this 5 into this equation, y equals x plus 5, I have 5 plus 5, or y is equal to 10. Again, the exact same answer. And that's what we would want to see. If we don't see the exact same answer there, you need to now question whether or not you did the right work to begin with for this step. So now I have an answer. I have an x value and a y value. So we know when we're talking about a systems of equations, we're looking at an intersection point, meaning we need to find an x comma y. We need to find a coordinate pair that matches and is true for both of these two situations. And so we just found that. And so we can write our answer now as an ordered pair. We can say 5 comma 10 is the solution to this. And we can check our work. We can say, okay, if I put 5 in here, 2 times 5 is equal to 10, and 10 is equal to 10. So that works out. 5 plus 5 is equal to 10, and our y is equal to 10, so 10 equals 10. So we can check our work afterwards, which I highly recommend you do. I think you should always do it. I just did it. Again, you can check your work in your head. However, again, you might make a mistake. So writing it down is an okay thing too. I just ran out of space. All right, so your ultimate goal with solving by substitution is going through some sort of logical thought process. This is my logical thought process, broken down into steps for you. If you don't like this, you can change it up a little bit. But biggest thing is you're going through some sort of logical algebraic thought process to get x and y and then turn them into a coordinate pair that is a solution to both of your equations in your system, okay? All right, so 2 more videos. They're gonna get gradually more difficult, and then you can start working on the must-do practice problems. I'll try to make the next 2 a lot quicker. Thank you for watching. Bye.